Here we go. Chapter 7, standardized test, practice number 2 on your worksheet or in the book on page 201. So it's chapter 7, standardized test, practice number 2. Okay. The illustration below shows a satellite in orbit around a small planet. Satellite's orbit radius is blah, and speed is blah. What is the mass of the planet around which the satellite orbits? Okay, so before I even put in the numbers, let's think about what formula we're going to be using here. We are given the orbital speed and orbital radius. We're asked to find the mass of the planet around which it orbits. So we're going to be using our orbital velocity formula, which is v equals the square root of gravitational constant times the mass of whatever you're orbiting. Let's say the mass of the thing being orbited. Usually it's Earth or the Sun. In this instance, it's some planet, so let's call that P. The mass of the planet divided by the radius. Now we're given the velocity. The velocity is... it gives us its speed. It's 2 times 10 to the 5th meters per second. 2 times 10 to the 5th meters per second. What is the mass? Radius is 6.7 times 10 to the 4th kilometers. Radius is 6.7 times 10 to the 4th kilometers. And guess what we're going to do? We're going to put this into meters because you always want to use SI units. If you haven't caught on yet, you just add a factor of 3 to our power of 10 when converting from kilometers to meters, because again there are 1,000 meters in every kilometer. Okay, so and we know our constant G equals, the question gives it to us, 6.67. Whoa. What was that? 6.67 times 10 to the negative 11 Newton meters squared divided by kilograms squared. Okay, and then if you guys caught on yet, we're just gonna plug in our values and then solve for our mass of the planet. Actually, I'm going to do this algebraically first before I plug my numbers in, so I don't have to drag those big numbers around. So the first thing I have to do is get rid of the square root, so I'm going to square both sides. So that'll give us v squared equals g times the mass of the planet divided by r multiplied by r. V squared equals g m p. You guessed it, divide by g. So that will give us r v squared over g equals the mass of the planet. So just rewriting that over here, r v squared, whoa, our radius is 2 times 10 to the 5th meters per second. I'm sorry, our radius is 6.7 times 10 to the 7th meters. 6.7 times 10 to the 7th meters. Our velocity is 2 times 10 to the 5th meters per second. 2 times 10 to the 5th meters per second. And that's squared divided by our gravitational constant of 6.67 times 10 to the negative 11 Newton meter squared kilogram squared. So the mass of this planet is, pausing to count. Alright, calculations are done. The mass of this planet is 4.017, and that's going to be a mass, so it's in kilograms. And if we broke down newtons into kilogram meters per second, it would work out where these units cancel out, leaving only kilograms, but I'm not going to do that in this video. If you take a look at, it's actually 4.017 times 10 to the 28th. I'm sorry, I forgot that. 4.07 times 10 to 28th kilograms. Alright, if you take a look, that's D. Alright guys, see you at number 3.